In Unit 3, we're going to look at limits and continuity, and in Section 3.2, we're going to look at a visual approach to limits. So what is a limit? Shown here is the graph of a function x minus 1 squared. And by examining the graph, we're asking what is the limit as x approaches 3 of x minus 1 squared. And what that means is as my x values on my function approach 3, what are my y values approaching? Well, if we examine the graph, as I approach 3 from this side, my graph is approaching the value of 4 from below 4. And as I approach 3 from this side, my graph is also coming down towards the value of 4. So it appears that the limit as x approaches 3 of the function x minus 1 squared is equal to 4. Okay, so basically when we're looking at limits, we have to look at what is the y value of the function approaching as the x value is approaching a certain value. So let's take a look at the intuitive limit definition. And it says if x approaches b, and b would be our x value from both the right and the left, and if the function f of x approaches the same single number, then this is called the limit of the function, and we can write the limit as x approaches b of f of x equals L. So let's take a look at an example. We want to examine the following graphs and answer the following limits. So we want to know the limit as x approaches 0 in part A. Well, here's where x is 0. As I approach 0 from the left and the right, the graph is approaching the value of 1. So the limit as x approaches 0 is 1. The limit as x approaches 3, well, as I approach 3 from the left and from the right side, the value of the function at 3 is approaching 0. As I approach -1, as my x values approach -1, my graph is approaching this value right here, which is going to be 2. Get rid of some of those. The limit as x approaches -2. Well, as I approach -2, as my x values get closer and closer to -2, the y values are approaching that open circle. Now, they're both approaching the same open circle, which is situated at 3. So even though there's no value of the function at -2, there's still a limit. The graph is approaching 3 from both sides. For question E, the limit as x approaches 2. Well, the limit as x approaches 2, my graph is both approaching this open circle, and that y value would be -2. Now, that is not the same thing as the value of the function. So for E, if I asked you what is f of 2, so basically what is the function as x is 2, well, the value of the function would be this dot, which would be 1. So in this particular case, the limit and the value of the function are not the same thing. And we'll talk more about that later. And the last one, the limit as x approaches -3. So as the graph approaches -3 from the left and the right, the y value is approaching 2. Okay, for limits that do not exist. In order for a limit to exist, the limit from the left side of x has to equal the limit from the right side of x. And if we take a look at this example, the limit as x approaches 0 from the positive side. Well, here's where x is 0. Coming from the positive side, I'm coming along this path. Coming from the positive side of 0, my limit is 3. Coming from the negative side of 0, which means the left side of 0, and that's denoted by this little negative sign here, that limit is going to be approaching 1. So the limit coming from the right of 0 and the left of 0 are approaching different things, so therefore the limit as x approaches 0 does not exist. Okay, let's take a look at some of these. So first of all, the limit as x approaches 2. Well, notice as I approach 2 from the left and the right, the graph is approaching the y value of -3. As I approach 0, coming from the left and the right, the y values are approaching 0. As I'm approaching -2.5, which is right about there, the graph is approaching from the left and the right, they're both approaching the y value of 2. The limit as x approaches 1, well, coming from the left of 1 and coming from the right of 1, they're both approaching that open circle of 1. Now, f of 1 is asking me what is the y value when x is 1? Well, when x is 1, there's a solid dot at -2. F of -2 is saying when the x value is -2, what's the y value? Well, I have to go to the solid dot, and at -2, the solid dot is at +2. Now the limit as x approaches -2 from the positive side means I'm coming from the right side of -2, and that value is approaching -2. As I approach -2 from the left side, the graph is approaching +2. So therefore, the limit as x approaches -2 does not exist. Why? Because the limit from the left does not equal the limit from the right. Okay, looking at infinite limits. Okay, so let's take a look at this graph. And we're asking you, what is the limit as x approaches infinity? Well, as x approaches infinity, that means the graph is going further and further to the right. So as this graph goes further and further to the right, the y value is getting smaller and smaller and smaller, and it's approaching 0. As x goes to -infinity, that means as I go further and further to the left, well, the graph is getting higher and higher to the x-axis. It's also approaching 0. In this example, we're asking for the limits as x approaches 2 from the positive side. And notice at 2, I have a vertical asymptote. And as I approach 2 from the positive side, my graph is going up forever and ever. It's going to positive infinity. As I approach 2 from the left, the graph is also going up and up. It's also going to positive infinity. And therefore, the limit as x approaches 2, well, from the left, it's going to infinity. From the right, it's going to infinity. So therefore, we could say it is going to infinity. Now, some textbooks will say the limit as you approach a vertical asymptote does not exist because infinity isn't really a value. But again, our textbook says that the limit is infinity. And that's the notation we will use. Okay, taking a look at the next example, we want the limit as x approaches 3 from the positive side. Well, from the positive is the right side of 3, and that graph is going on forever and ever in the upwards direction, so it's going to positive infinity. Coming from the left side of 3, the graph is going down, so it's going towards negative infinity. So if I asked you for the limit as x approaches 3, you would say it does not exist because the limit from the left doesn't equal the limit from the right. Okay, I want you to pause the video and I want you to give this one a try. Okay, hopefully you've had a chance to try this. So again, we'll go through the answers here quickly. F of -6 is the y value at -6, which is going to be 7. F of 0 is the y value when x is 0, and it's 0. F of 3 is the y value when x is 3, and that's going to be 1. F of -4 is going to be the y value at -4, so we have to take the solid dot, which is 3. And f of -3, it has an open circle, so this does not exist. The limit as x approaches 1. Well, the limit as x approaches 1, coming from the left and the right, they're both approaching the y value of 1. The limit at -5 is going to be +5. The limit at 0 is going to be 0. The limit at 3, well, coming from the right of 3 and the left of 3, those values are both approaching 2. Approaching -4 from the positive side, so -4 from the right is approaching 1. -4 from the negative side is approaching 3. Therefore, the limit as x approaches -4 does not exist. Limit as I approach 2 from the positive side, it's going up forever and ever. It's going towards infinity. From the negative side, it's also going towards infinity. So therefore, the limit as x approaches 2 is infinity. The limit as I approach -2 from the positive side, the right side, it's going down. So it's going to negative infinity. -2 from the left is going up. It's positive infinity. And therefore, the limit as x approaches -2 does not exist. Now, the limit as x approaches infinity. I'm only worried about the furthest right part of my graph because that's where x is going to infinity. And as it's going towards infinity, it's actually approaching the value of 1. And as x goes to negative infinity, okay, that means the very furthest left of the graph will have a linear function that is going up and up. So as the graph goes further left, it goes further up. That one would be going to positive infinity. Okay, so there is your assignment, page 122, the oral exercises. Numbers 3 to 8, 12, 13 to 20, and on page 123, numbers 8 to 13. Give those a try and see how you do.